Lots of the commands we've been doing have been looking at what is inside an object. Sometimes we've taken the default display, sometimes we're seeing a list of things in them, and we've even done a few commands to get extra properties out of objects. Going beyond the bare minimum with PowerShell requires you to have some idea of what is available to you in objects that you're working with. Many objects have a default display that doesn't show the properties directly at all. For example, the getDate commandlet displays a very pretty string showing the date and time, but does not show things that are already built into the date time, for example, the time zone, the day of the week, and things like that. The system clock that is used to get that data can provide much more detailed and accurate, precise timing than we're seeing in the default output. Why? Because the default output is for a human who just wants to know what the current date and time is. But the object that is produced has far more data available if we know how to get at it. So a very important skill when you're learning to use PowerShell, and even after you've learned to use it and you're continuing to use it, is to know how to figure out what objects you have and what is in them that you can use. Microsoft does provide some tools to help with this. The number one tool to use is the get-member commandlet. The get-member commandlet can accept an object or collection of objects either on the command line as parameters or coming from a pipeline. The get-member commandlet shows us what type of object we have and tells us the name of the data type for that object. Shows us a list of all of the things that are in it that we can see and touch and do things with, organized by the type of member in the object. It also gives us information about each of those items, such as whether they can be changed or not, how to use them, what kind of data to expect from them, and for methods, what kind of data we might have to give them to make them do their job. The primary things that we're interested in are the methods, which is code, things we can ask the object to do for us, and properties, data items that are stored inside the object that we can retrieve to either get information from the object or we can set to give an object data to work with. There are lots and lots of other kinds of members. There are aliases, which simply provide alternate names for properties. There are note properties, which are text versions of properties. There are script properties, where a property, instead of containing an object, will contain a function that you can run and produce dynamic data, and so on. There are many other kinds of members. Some of them are quite exotic. Not all of them can be directly worked with. Sometimes you need to run a method to produce the data you want. Sometimes you can get the data you want just by looking at a property. Get-member is designed to show us the properties and methods and other members that might be of interest to us on a normal basis. Objects can have additional members, extra properties, that are hidden by default, ones that we cannot see for various reasons. Names for those extra things include adapted or extended properties. In order to use those, you need to know they exist. Get-member has a special parameter called -view, and if you specify all as the view, you'll actually get a more complete list that does include adapted and extended properties for some objects when they have them. It is a good starting tool. Let's try some examples. We're going to work with a couple of commandlets that we've seen because we're already kind of familiar with what they produce, and we would like to see what it is they're coming from. So for example, one of the very first commandlets we ran was get host. We used this to find out what version of PowerShell we were running. When we ran getHost, we got a list of things out. Each item has a name, and each item has something in it. By now you should be recognizing the names on the left are property names, and the things on the right are the text display of the objects contained in those properties. For example, the name property contains an object that, when displayed, prints out a string console host. In other words, the PowerShell process. Version prints out a series of numbers with dots, looks like a string. Instance ID, again, a string of characters. The UI property is printing out that dotted name we've seen before from out grid view and so on. And at this stage, we recognize that means that the object or object array stored in the UI property is too complex to display as simple text here. So instead, we get its data type name, the type of object that is stored in the UI property. And so on for the rest of these. If we wanted to know what kind of object came from getHost, what is its type name? What kind of other things are in it that we might be able to see other than the default things that got displayed? We can create that object with the getHost commandlet, and instead of letting it display, we can pipe it to the get-member commandlet. The get-member commandlet will examine any objects we give it, print out what kind of objects they are, tell us the type name, and show us a list of the members. So here is the definition of the object it received from the getHost command. The type of object it got is a system management automation internal host object type. The short name that we might use to refer to this would be just the word internal host, the last element. It's not uncommon amongst object-oriented programming people to simply refer to object types, or what we call class names, by using the last portion of it. It's much easier and quicker to say for people who are familiar with the types of objects in here. This whole name is written this way because there's a system object. And the system object has been used to create a management object based on system. That one has been used to create an automation object based on system management. There's an internal object created from the system management automation, and so on. These are subclassed from each other. That means that each time we take one of these names, we add some things to it, remove some things from it, change how some things work, and it creates us a new object type. It's a hierarchical naming scheme. To see another type, we might use a different kind of object. For example, we could take our object that comes from getDate that prints out our pretty date and time string and send that to getMember. And it will list out what that is composed of. And if we look at the start of that output, we'll see that its type name is actually very simple. It's a system.datetime, or as we commonly call it, a datetime object. The list of things that are contained within these objects are different. These are different object types. They have different definitions of what is contained in them and what they can do. The list of members includes a name, a type of member, and the definition of that member. What is it? What's in it? For example, there's a member here called enter nested prompt in our internal host object. That member is a method, so this is the name of an action that we can ask the object to take. Its definition is void, then the name of the method, followed by parentheses. In this case, they're empty. The next method has a different name, a different start, the same, its name repeats here, and inside its parentheses is a definition of a parameter. So when we run enter nested prompt, what this definition is telling us is that we can run it with no parameters, the parentheses are empty, and it will never give us back any output. That's what void means. If we use the equals method, we can only use it if we have some kind of object to give it as a parameter. And when this method runs, when the host object runs this method, runs the code, it's going to produce a Boolean for us, a true or false. So this is actually used to compare two objects and tell us if they're equal. Methods can return any data type or return void. When they return a data type, they may return a collection of objects, they may return a single object. Even if they have a data type specified, the object they return may potentially be an empty object, the special value null. Some methods are very common. We find them in many objects. For example, the equals method. GetType is another very common one that we should know about. ToString is another very common one we should know about. When we ask the object to run its ToString method, we don't have to give it any data to run on. It uses the properties contained in the object, and what it produces is a string, a printed version of the object, something we can see. When we have a property member, the name on the left is our property name. On the right, we have a data type contained in the property. The property name gets repeated, and we're told if we can only get the value in it, or whether we can get it or choose to change it, to set it. So we can see here, for example, there is a property called debugger enabled. It's a Boolean. It can be true or false. We can retrieve the value of it. We can see if it's turned on or not in the current PowerShell. And we have the option that we can change it. If it's currently false, we could set it to true. If it's currently true, we could set it to false. So properties can be retrieve only, can be retrieve and set. The list of methods will be appropriate to the object type. For example, there are many different methods contained in a date-time object that are useful and relevant to working with dates and times. Putting those methods in something like a PowerShell host object would not be useful. It doesn't work with those data types. So to know what you can do with an object and what is contained in an object, get-member can be very helpful. Note that the list can be very long. So it is not uncommon to use the -member type parameter when running get-member to only see a certain type of members. For example, if I only wanted to see the ordinary properties from the date-time object, I could run my getDate to produce one of those objects, pipe that to get-member to examine the object, and instead of letting it make the entire list, I can tell it I only want to see things that are member type property, and I will see the ordinary properties only. Note that there were some strange looking property types in our date time, a note property and a script property. If I want to see all kinds of properties, but only properties, I can do the same command, and instead of asking for member type property, I can ask for member type properties to see all the different kinds of properties that might be in this object. And I'll see them all. This list that comes out may be long. You may wish to pipe this output to more. And bear in mind, just because you've got an object of a type that looks like the thing you want, that doesn't mean it's the only object that might have what you want. For example, the get process commandlet, to remind us, produces a list of the processes that are running because it gets a list of processes and makes objects from them. If we wanted to know what was in process objects, we could pipe that to a get member. And we would find that process objects have a very long list of properties in them. We sort of already knew this from when we did our out grid view exercise and saw this list of property names. As you look through this list of property names, it may occur to you that nowhere in this list do we find a username. Nowhere in here does it tell us who is running these processes. So if we use the get process commandlet to try to figure out who is running the processes, we're going to be disappointed. The data is not easy to find. You could dig further. You could try to find it buried somewhere inside an object, inside an object, inside an object there. Remember, properties contain objects. Those objects have properties which contain objects. Those objects have properties which contain objects. And you can dig down through them and eventually maybe find the data you want. Or you could simply start with a different type of object. There is another command, get WMI object, that you can give an option to go get a specific type of Windows Management Instrumentation object or WMI object, and we'll ask for the Win32 process objects in the system. So just like get process, it's going to figure out a list of the processes running on the system, but instead of producing the objects that were produced by get process, we're going to get a different kind of object, which has a different structure, a different list of members. To see what's in this one, we can pipe that to get member, and we'll find that it has a different list that shows us information about the process. And when we start looking through this one, we'll eventually find that there's some information in here we can use to figure out who is running the process. So if you have an object that isn't giving you the data you want, don't assume that means you can't get it. You may simply need to find another object type. Microsoft's TechNet website is very good for this. And of course, even Google can be used, although I will give you fair warning, you may spend a lot of time following dead ends, wrong leads, and incorrect commands, because Google will find anything anywhere without any concern for whether or not the person posting things has any idea what they're doing or talking about. I'm sure you've already encountered this. So each property has a data type. Each property has a name. And of course, the objects have a type. So we noticed that when we did the get WMI object, what we got out was a system management object of type Win32 process, like we asked for. When we ran get process, we got a system diagnostics process object, which is another type of process object. It's simply a different one. Methods deserve just a little more discussion. Methods are ways of asking an object to do something. Methods can be thought of as functions. So there is a block of code that is built in to a method, which is the instructions for the object to do something. Some methods don't allow us to give them any parameters, no data. They just go do a predefined function. Other ones require us to supply one or more objects, perhaps of a specific type, perhaps not. System.object is a generic name that says we can pass through pretty much any kind of object we want. If your method lists multiple parameters, then you can supply values for those. Methods are invoked using dot notation. Parameters are accessed using dot notation. Parameters return objects, so do methods. The only time that methods don't is if they are type void. You cannot have a property that is type void. Not in anything we're going to do. One of the important things to remember about methods: when you invoke or tell an object to run a method, the object runs the method. The code is stored in the object. It is not PowerShell that knows how to do whatever the method is. PowerShell only knows how to tell the object, go do this for me and give me the output. This is really important. It means PowerShell can be extended infinitely by simply creating more objects that have more code. Anything that we can tell an object to do, we can get done with PowerShell.